In order to understand the concepts behind multiplication and division, it is important to first start with the understanding of what an array is. Factors are numbers that are used to create a multiplication problem. In the example below, 7 times 6, the 7 and the 6 are factors, and they equal the product of 42. The product is the answer to a multiplication problem. Multiples are numbers we land on when we skip count. So when we sing 3, 6, 9, 12, we are essentially finding all the multiples of 3. When you look back up at the number 42, 42 is a multiple of 7, since if I skip count by 7 6 times, I'm going to arrive at 42. 42 is also a multiple of 6, since I can skip count 7 times and land on the number 42. An array is a group of items with the same number of items in each row and the same number of items in each column. So when I'm looking at an array, what I'm looking at is, does it have the equal rows and columns? So in this array, I have 3 items in every row. All the rows have 3. I have 3 items in every column. Now this is a square array. Some arrays will not have exactly the same number of items in each row as they do in each column. This is an example of what is not an array, because if I look at it, I have only 1 item in this column and 2 in this one. So it would not be an array since it doesn't form some sort of a rectangular shape with its parts. A prime number is a number that has only 2 factors, one in itself. Composite numbers always have more than 2 factors. And a square number is a number that has an odd number of factors and has the same number of items in each of the rows as it does in the columns. It makes a square. This is a 1 by 1 array, meaning that it is 1 square unit. So its area is 1 square unit. A 1 by 1 array is not prime because prime arrays need 1 and another factor. The array of 1 is not composite. The number 1 is not composite since it only has 1 factor of 1. But it is a square number since all the lengths of its sides are equal. If I was to find the perimeter of this shape, that is what I find when I walk around the outside and count sections. So the perimeter would be 1, 2, 3, 4 units. When I see this 2 by 1 array, what I want to make sure you understand is that we have 2 square units in the array, 2 shapes of the same size, so that we call it a 2 square unit array. That doesn't mean the array itself is square. This is a prime number because it has the factors of 1 and 2, factors of only itself and the factor of 1. It is not composite because it doesn't have more than 2 factors, and it is not square since this array makes a rectangle but not a special rectangle called a square. To find the perimeter of this shape, I would once again pretend as though I'm walking around a park. So I'd be 1, 2, 3, 4, 5, 6. Though my 1 by 3 array makes a rectangle and not a square, we still want to make sure we notice it has 3 square units in the array. It is again a prime number since its only factors are 3 and 1. And since it only has 2 factors, it's not composite, and the shape of the array is not a square. The perimeter would be found by walking around the edges, which would be 1, 2, 3, 4, 5, 6, 7, 8 units. We finally reached an array that is composite. And this array is composite because it can make more than one array with its factors. So if I say the array has the factors of 1 and 4, it is making a 4 by 1 array, meaning that I can count 4 square units in that array. However, this array also makes a square array of a 2 by 2 array. And this array again will have 4 square units, but will have a different perimeter. The factors of 4 will be 1, 4, and 2. And this is an odd number of factors, so this array is a square array, also makes the square. Since there's more than one array to make this number, it is composite. The 4 by 1 array is going to have a larger perimeter because each of the vertical sides are 1, so 1 plus 1 is 2, and each of the horizontal sides have 4 units. 4 plus 4 is 8, plus 2 is 10. Notice that even though these are both arrays representing the number 4, the 2 by 2 array only has a perimeter of 8. Notice that 4 is a multiple of 2. If I skip count by 2's, I get 2, 4, 6, 8, 10. Once I have multiples of 2 as numbers, I will never again have a prime array that is an even number. 2 is the only even prime number. The 5 by 1 array is 5 square units. And it has only 2 factors, 1 and 5, so it is a prime number. The number 6 is a multiple of 2, so I know it's going to be a composite number with more than 2 arrays, and its factors are 1 and 6 and 2 and 3. It has an even number of factors, therefore it is composite but not square or prime. Notice that when I look at the perimeter of these two 6 square unit arrays, their perimeters are not the same. Since 7 is not a multiple of 2 or a multiple of 3, the next prime number we've reached, 7 is a prime number. It only has its 2 factors, 1 in itself. There's no other way using whole numbers I could create a multiplication problem with factors that would have the product of 7 other than 1 by 7. This 8 square unit array has 2 possible arrays. You'll notice that there are 8 squares in each one. So it's a 1 by 8 array, or it can be a 2 by 4 array. Its factors, therefore, would be 1, 8, 2, and 4. This is a composite number. It has an even number of factors. And notice how we get the perimeter. The perimeter of the 2 by 4 array is going to be smaller, less units than the perimeter of the 1 by 8 array. When I skip count by 3's, which was a prime number, 3, 6, 9, 12, 15, 18, any of those multiples after 3 are always going to be composite numbers, creating more than one array. In this case, we have a 9 by 1 array, and we have a 3 by 3 array, which are both 9 square units. And we also do have a square array. So the number 9 would be considered a square number, and it would also be considered a composite number since there are more than 2 factors. Remember, the factors of 9 are only 9, 1, and 3. We don't repeat the factors twice. We only list each of the factors being used once. There are many numbers that will have more than one array, and I wanted to quickly look at the number 12. It is a multiple of 2. If I skip count by 2, I land on it, so 2 will be one of its factors. It's a multiple of 3. Since if I skip count by 3, it would land on 12. And 12 is also a multiple of 4. If I skip count by 4, I would land on 12. So there are a number of factors in this number, the numbers that I would use to land on to get to 12. Of course, my first array would be the 1 by 12 array, but then I know that 12 is an even number, so I can complete a 2 by 6 array. And I also know that 12 is a multiple of 3, so I can create a 3 by 4 array. Therefore, my factors will be 1, 12, 2, 6, 3, and 4. Since this number has an even number of factors, it is a composite array, since none of the arrays made contain a square array. It is composite but not square. I hope this gives you a start into understanding the use of arrays and the importance of understanding prime, composite, and square numbers, and finding factors of all numbers.